Hello, today, as always, we are embarking on a journey into one of history's most enduring mysteries. Our story begins in the post-war optimism of mid-century America, a time when humanity first gained the technological confidence to seriously listen for voices beyond our world. In the quiet fields of Delaware, Ohio, an ambition was taking physical form: the Ohio State University Radio Observatory, more famously known as the Big Ear. Conceived by the visionary astronomer and engineer Dr. John D. Krause, this was not merely a telescope, it was a landscape-sized instrument, a testament to brute force radio astronomy. Its design was brilliantly unorthodox. While most telescopes are steerable dishes, the Big Ear was a fixed colossus, a cross-type design that used a massive, flat reflector and a tiltable flat plane to capture cosmic whispers. It relied on the Earth's own relentless rotation to scan the heavens, a patient, methodical process where each patch of sky would only be in its view for a brief, precious window. Built from over 200 tons of steel and aluminum, its construction was a feat of community and perseverance, involving university staff, students, and even local farmers. It stood as a silent sentinel, a giant ear cupped towards the stars, embodying a profound question: in the immense silence of the cosmos, if someone calls, will we be listening? To truly grasp the miracle of the wow signal, we must delve into the exquisite mechanics of how the Big Ear performed its cosmic vigil. Picture the telescope not as a searching eye, but as a fixed gate through which the universe paraded. As Earth rotated, the sky drifted slowly across its twin receiver horns, each scanning a slightly different patch of space. Any celestial object would spend exactly 72 seconds in the full sensitivity of each horn. This number is not arbitrary, it was dictated by the telescope's fixed width and the planet's rotational speed. This was its fundamental rhythm, the exposure time for any single point in the cosmos. Its electronic ears were finely tuned to a specific, hallowed frequency, 1420.4056 MHz. This is the natural resonance frequency of the hydrogen atom, the most abundant element in the universe. The logic was impeccable: any advanced civilization seeking to announce its presence would use this universal watering hole, a channel known to all galactic scientists. The data it collected was a river of alphanumeric code numbers 1 to 9 for low intensity, and letters AZ for higher intensities, printed on endless, green-barred computer paper. It was a slow, analog, and profoundly human process of seeking a single meaningful word in an endless, chaotic novel of static. The Big Ear was not an isolated instrument, it was the spearhead of a radical scientific endeavor known as SETI, the search for extraterrestrial intelligence. This field was born from a convergence of Cold War radio technology and a timeless philosophical yearning. In 1959, physicists Giuseppe Cacconi and Philip Morrison published a seminal paper in the journal Nature, arguing rationally for the search at the 1420 MHz frequency. A year later, astronomer Frank Drake conducted Project Ozma, the first organized SETI experiment, pointing a telescope at two nearby stars. The Big Ear survey was a direct descendant of these pioneering efforts, but on a grander, more systematic scale. It was a project fueled by equal parts rigorous science and audacious hope, often operating on a shoestring budget with a small team of dedicated researchers and volunteers. They faced skepticism from the broader scientific community, who saw it as a quixotic quest for little green men. But for these pioneers, it was a necessary experiment. The silence of the universe was a data point that could only be confirmed by listening, and the potential payoff, the knowledge that we are not alone, was worth a lifetime of patient, meticulous, and often thankless work. They were building the apparatus for what could be the most profound discovery in human history. Every great discovery needs a discoverer, and in this story, that man was Jerry Ehman. He was not a starry-eyed dreamer, but a serious scientist with a PhD in radio astronomy and a background in physics. A volunteer for the Ohio State SETI project, his weekly ritual was one of almost monastic dedication. He would drive to the observatory, collect the thick stacks of fanfold paper that represented days of cosmic listening, and take them home to analyze. His tool of choice was a simple red pen. His mission, to scan the endless columns of numbers and letters, looking for any anomaly that broke the monotonous pattern of ones and twos that represented the background hiss of the universe. This was before machine learning algorithms could sift data. It relied on human pattern recognition, on the sharp eye and patient mind of a researcher. Ehman was the perfect man for the job: meticulous, disciplined, and deeply knowledgeable about the instrument and the data it produced. He understood the significance of the 1420 MHz frequency and the telltale signature a genuine signal would have. He was, in essence, a codebreaker, trying to find a single, intelligible sentence in a library of random noise, a library that grew larger with every passing day. The stage was set on a warm, unremarkable summer evening, August 15, 1977. At the Perkins Observatory, the Big Ear was performing its silent, mechanical ballet, its focus directed by the Earth's rotation towards a rich starfield in the constellation Sagittarius, near a star known as Chi Sagittarii. This region, dense with the stars of our Milky Way's galactic center, was a prime target, a bustling celestial metropolis that offered a higher probability of harboring life. Inside the control shack, the only sounds were the hum of electronics and the rhythmic chatter of the line printer, inscribing its cryptic language onto the continuous paper. The telescope's dual-horn system was operating flawlessly, with the second beam serving as a crucial cross-check against local interference. For 72 seconds, as the Earth turned with imperceptible slowness, a specific point in that starfield drifted through the telescope's unwavering gaze. During that brief window, something extraordinary happened. The universe, for a single, fleeting moment, broke its silence. The signal that flooded the receivers was so powerful, so statistically impossible, that it would have been visible even to a much smaller, less sensitive instrument. Yet, in that moment, there was no alarm, no flashing light, just the silent, unobserved recording of data onto magnetic tape and paper, a secret waiting to be discovered days later. Several days later, Jerry Ehman sat down with his weekly stack of printouts, his red pen in hand. The ritual began as it always did, a methodical, line-by-line examination. Then, his rhythm shattered. His eyes locked onto a sequence on the page for the second beam, 6EQUJ5. His mind, finely attuned to the telescope's language, instantly decoded the message. This wasn't a minor fluctuation. The signal intensity had surged from a background level of 1 or 2 to an incredible 6. It then escalated through the alphabet, E, 14 times background, Q, 25 times, peaking at an unprecedented U, a staggering 30 times louder than the ambient noise of space. Then, just as sharply and cleanly, it descended to J in 5. This perfect, Gaussian bell curve was the unmistakable signature of a point source moving through a fixed beam. It was artificial in its perfection. The signal was also narrowband, concentrated almost entirely on the sacred 1420 MHz frequency, a characteristic of engineered transmission, not natural phenomena. The sheer, breathtaking improbability of it all, the power, the frequency, the perfect shape, left him momentarily stunned. In a spontaneous overflow of pure, unvarnished awe, he picked up his red pen, drew a firm circle around the alphanumeric sequence, and in the margin, wrote the 3-letter exclamation that would echo through history, "Wow!" The initial wow was followed by a surge of scientific adrenaline and rigorous skepticism. Ehman immediately contacted the project director, Dr. John Krause, and colleague Robert Dixon. The first and most critical step was to rule out any and all terrestrial or human-made sources. Could it have been a secret military satellite testing a new transmitter? A reflection from a passing aircraft? Or perhaps radio frequency interference, RFI, from a ground-based source, like a passing car or a malfunctioning electrical appliance? The team embarked on a meticulous forensic investigation. They cross-referenced the exact time and coordinates with satellite databases and aircraft flight logs. They scrutinized the signal's properties. Its narrow bandwidth made it unlike any known natural cosmic source, and its intensity profile was inconsistent with a nearby, moving object. The fact that it appeared in only one of the telescope's 2 horns was particularly telling. It confirmed the signal was celestial, not a local glitch affecting the entire system. Each dead end they reached, while frustrating from an immediate explanation standpoint, simultaneously elevated the signal's status. The absence of a prosaic answer was, in itself, a powerful piece of evidence pointing towards something extraordinary. Once internal checks were exhausted, the news of the signal began to ripple through the small, specialized world of SETI and radio astronomy. Ehman and Krause published their findings in a low-key manner, but the implications were seismic. The WOW signal quickly became the subject of intense discussion at conferences and in university corridors. It was the first, and to this day remains the best, candidate signal that perfectly fits the pre-established profile of a potential interstellar beacon. It had the right frequency, the right bandwidth, the right intensity profile, and the right duration. However, its singularity was its greatest weakness from a scientific standpoint. The gold standard of science is repeatability, and the WOW signal's refusal to reappear made it impossible to verify independently. This single, brilliant data point became a Rorschach test for the scientific community. Optimists saw it as a tantalizing piece of evidence that we were on the right track. Skeptics, while acknowledging its intriguing nature, classified it as an unsolved anomaly, a compelling ghost story that lacked the substance for a definitive conclusion. The debate had begun, and it would continue for decades. The most crucial test was yet to come. Could they hear it again? Armed with the precise coordinates, the team at Big Ear initiated one of the most patient and poignant experiments in scientific history. They pointed the telescope back at the same spot and listened. They scanned the region not just once, but dozens, then hundreds of times. They expanded the search to a wider area, considering the possibility of slight errors in pointing or an intermittent source. For months, and then years, the giant ear remained trained on that sector of Sagittarius. But the cosmos offered only its familiar, crushing silence. The printer produced reams of paper filled with nothing but the gentle hiss of the universe. The signal's singular, brilliant appearance and its subsequent eternal absence made it both legendary and scientifically maddening. It was as if a door in the universe had opened for a breathtaking instant, giving humanity a fleeting glimpse of a profound secret, only to slam shut forever, leaving us with nothing but the memory of the light and a lifetime of questions. This relentless, unanswered listening became a powerful metaphor for the human condition in a vast and seemingly indifferent cosmos. As years passed without a repetition, scientists worldwide began proposing natural explanations, each attempting to tame this cosmic anomaly within the bounds of known physics. One prominent hypothesis suggested the signal might have originated from a comet, specifically, that neutral hydrogen clouds surrounding comets like 266P/Christensen or P/2008 Y2, Gibbs, could have emitted the signal as they passed through that region of space. However, this theory faced significant challenges. Detailed orbital calculations showed these comets weren't in the right position in August 1977, and the signal's extraordinary intensity and narrow bandwidth didn't match the emission characteristics of cometary hydrogen clouds. Another compelling natural explanation involved gravitational microlensing, where the gravity of a foreground object like a star or planet acts as a cosmic lens, briefly amplifying a faint, distant natural radio source into a detectable signal. This could explain both the signal's strength and its transient nature. Yet, the probability of such perfect alignment to create a signal that precisely matched the hydrogen line frequency seemed astronomically low. Other theories included unknown astrophysical transients, plasma instabilities, or even signals reflected from space debris, but each failed to fully account for all the signal's unique characteristics: its perfect frequency alignment, Gaussian profile, and incredible intensity. The very fact that so many brilliant minds struggled to find a satisfactory natural explanation only added to the signal's mystique, pushing it further into the realm of the truly extraordinary. If natural explanations fall short, we must confront the staggering possibility that the WOW signal was artificial in origin. This hypothesis, while extraordinary, fits the data with unsettling precision. Consider the parameters: a signal precisely at the universal watermark of hydrogen frequency, a narrow bandwidth consistent with engineered transmission, and a strength suggesting a transmitter of immense power, possibly orders of magnitude beyond human capability. The 72-second duration perfectly matches what we'd expect from a fixed celestial source passing through Big Ear's beam. But if it was artificial, profound questions emerge about its purpose. Was it a deliberate beacon, a cosmic hello meant to announce a civilization's presence? If so, why hasn't it repeated? Perhaps it was an intermittent beacon sweeping through space like a lighthouse, and we simply caught one fleeting pulse. Or maybe it was leakage from an advanced civilization's activities, their equivalent of our early television broadcasts, but intentionally or accidentally directed into space. The most haunting possibility is that it was a one-time event, a final message from a civilization facing extinction, a last testament cast into the cosmic ocean. The implications of any artificial origin are profound, suggesting we might have briefly touched the presence of an intelligence so advanced we can scarcely comprehend its nature or intentions. The story of the WOW. Signal is inextricably linked with the fate of its discoverer. The Big Ear telescope, despite its monumental discovery, faced an increasingly uncertain future through the 1980s and 1990s. As radio astronomy advanced towards steerable dishes and digital technology, the fixed, analog Big Ear began to seem obsolete. The land it stood on became increasingly valuable, coveted for commercial development. The university's funding priorities shifted, and maintaining the massive structure became a financial burden. Despite a valiant fight by astronomers and supporters to save the instrument that had given humanity its most tantalizing cosmic mystery, the pressures of progress and real estate proved overwhelming. In 1998, the unthinkable happened. The Big Ear was dismantled, its components sold for scrap, the land cleared for a golf course and residential expansion. The irony was profound. The instrument that had detected what might be our first contact with alien intelligence was itself a victim of terrestrial concerns. The destruction of the Big Ear added another layer of poignancy to the WOW! Signal story. We lost the very ear that had heard the cosmic whisper, ensuring we could never use the same instrument to listen for a repeat performance, making the original detection even more unique and irreproducible. As scientific investigation continued, the WOW! Signal escaped the confines of academic journals and blossomed into a full-fledged cultural phenomenon. The simple, powerful image of the red-inked computer printout became an icon, appearing in documentaries, newspaper articles, and eventually permeating the emerging digital culture of the internet. It featured in television series like The X-Files, inspired episodes of science fiction shows, and became a central plot element in novels. Why did this particular anomaly capture the public imagination so powerfully? Unlike complex astrophysical theories, the WOW! Signal was democratically accessible. Anyone could look at the printout and understand that something extraordinary had happened. The human element of Jerry Ehman's handwritten WOW! Gave it an emotional authenticity that raw data lacks. For UFO enthusiasts, it became the closest thing to scientific proof of extraterrestrial intelligence. For skeptics, it remained a fascinating scientific puzzle. For the general public, it represented hope and wonder, the possibility that we're not alone in the universe. The signal transcended its scientific origins to become a modern myth, a symbol of humanity's eternal quest for connection in the cosmic dark. Throughout the decades of speculation and fame, Jerry Ehman maintained the careful, measured perspective of a scientist. In interviews and writings, he consistently expressed both the profound significance of his discovery and appropriate scientific caution. He never claimed to have found proof of aliens, always emphasizing that while the signal had all the characteristics they were looking for, its non-repetition prevented definitive conclusions. Ehman reflected thoughtfully on why this particular signal affected him so deeply. It wasn't just that it matched the expected profile, but that it did so perfectly, spectacularly. He often discussed the burden and privilege of being forever associated with this mystery, his name inextricably linked to those 6 alphanumeric characters. Despite numerous offers and opportunities to sensationalize his discovery, he remained a voice of reason, insisting that the WOW! Signal should inspire not wild speculation but better science, more sophisticated searches, and improved instrumentation. His personal journey with the signal represents the ideal scientific attitude, the courage to recognize and announce an anomaly, combined with the humility to acknowledge the limits of our knowledge. Ehman became the human face of one of science's greatest mysteries, a thoughtful, careful man who once wrote WOW! On a piece of paper and changed our view of the universe forever. The dawn of the 21st century brought unprecedented computational power to the search for extraterrestrial intelligence, allowing scientists to re-examine the WOW! Signal with tools unimaginable in 1977. Using sophisticated algorithms and machine learning techniques, researchers have conducted exhaustive analyses of the signal's unique characteristics, comparing it against comprehensive databases of known cosmic phenomena and human-made interference. The Allen Telescope Array, specifically designed for SETI research, has repeatedly targeted the Sagittarius region where the signal originated, employing millions of times more processing power than the Big Ear's original equipment. Meanwhile, projects like Breakthrough Listen use artificial intelligence to sift through petabytes of radio data from telescopes like Green Bank and Parkes, searching not just for an exact repetition but for any signal with similar properties across the galaxy. These modern investigations have ruled out entire categories of potential explanations, from rare atmospheric events to previously unknown astronomical transients. Yet paradoxically, as our technological capabilities have grown, the mystery has only deepened. The signal's perfect alignment with the hydrogen line, its precise bandwidth, and its Gaussian intensity profile continue to defy natural explanation, while its failure to repeat despite decades of improved monitoring remains one of astronomy's most perplexing puzzles. This technological evolution has transformed the WOW signal from a singular anomaly into a benchmark against which all potential SETI detections are measured. In 2016, a new hypothesis emerged that briefly reignited the scientific debate about the WOW signal's origins. Astronomer Antonio Paris proposed that the signal might have been caused by hydrogen clouds surrounding two specific comets, 266P/Christensen and P/2008 Y2 Gibbs, that were in the same region of sky where the big ear was pointed. According to this theory, the large hydrogen clouds that surround comets could emit radio waves at exactly 1420 MHz as solar radiation excites their hydrogen atoms. When Paris tracked these comets' historical positions, he found that 266P/Christensen was indeed in the vicinity on August 15, 1977. The scientific community responded with both interest and skepticism. Researchers attempted to detect similar signals from other comets, with mixed results. Critics pointed out significant challenges. The signal intensity detected was orders of magnitude stronger than what cometary hydrogen clouds typically emit, and the narrow bandwidth didn't match the broader emissions expected from natural cosmic phenomena. Additionally, detailed analysis of the Big Ear's beam pattern and sensitivity suggested that a comet would need to be emitting at impossibly powerful levels to create such a strong signal. While the comet theory provided a creative natural explanation, it ultimately failed to fully account for the signal's extraordinary characteristics, leaving the mystery fundamentally unsolved but demonstrating science's ongoing effort to explain even its most tantalizing anomalies through natural processes. The most philosophically challenging aspect of the WOW signal remains its profound singularity. Why has nothing like it ever been detected again, despite decades of increasingly sophisticated searching? This paradox forces us to confront fundamental questions about the nature of scientific evidence and the universe we inhabit. If the signal was natural, why don't we observe similar phenomena regularly throughout the cosmos? Rare natural events do occur, but they typically leave some trace, recurring patterns, similar events elsewhere, or predictable behavior. The WOW signal stands alone in its perfection and isolation. If the signal was artificial, the implications are even more staggering. Was it a targeted message that we failed to comprehend or respond to properly? Could it have been a cosmic lighthouse whose beam sweeps past Earth only once every few thousand years? Or perhaps it represents a technology so advanced that its communications appear to us as transient, inexplicable flashes? Some theorists have even proposed that the signal might have been a one-time event from a civilization that subsequently destroyed itself, a final testament to a now extinct intelligence. The silence that followed those 72 seconds may be as significant as the signal itself, speaking volumes about the challenges of interstellar communication and the possibility that the universe might be filled with the ghosts of civilizations that flashed briefly into existence and then vanished forever. The WOW signal's enduring mystery has fundamentally shaped the development of modern SETI research, transforming it from a speculative endeavor into a rigorous scientific discipline. Before 1977, the search for extraterrestrial intelligence operated on theoretical grounds. After the signal, researchers had concrete criteria for what a genuine candidate might look like. The signal influenced the design of next-generation detection systems, emphasizing the need for immediate verification protocols and multiple telescope coordination to eliminate the one-time-only problem that plagued the WOW detection. It spurred the development of real-time data analysis systems and prompted the establishment of protected radio frequency bands. The signal also broadened SETI's scope beyond simple radio listening to include optical SETI, searches for megastructures, and the hunt for technosignatures, indirect evidence of advanced technology. Modern initiatives like Breakthrough Listen, which commits $100 million to the search, directly acknowledge the WOW signal as inspiration for their comprehensive approach. The signal taught scientists to think critically about what constitutes good evidence and how to distinguish between interesting anomalies and potentially genuine detections. It remains the gold standard against which all potential SETI candidates are measured, a reminder of both the promise and the profound challenges of searching for needles in the cosmic haystack. Beyond its scientific significance, the WOW signal has provoked deep philosophical reflection about humanity's place in the cosmos. For centuries, we have wondered whether we are alone in the universe. The WOW signal represents the closest we've come to potentially having an answer. Its very existence, regardless of origin, challenges anthropocentric views of the universe and forces us to confront the possibility that we might be ordinary inhabitants of a cosmos teeming with intelligence. The signal raises profound questions about the nature of intelligence itself. Would we even recognize communication from a truly alien consciousness? The 72-second duration of the detection speaks to the practical challenges of interstellar dialogue across vast distances and timescales that dwarf human civilization. If the signal was artificial, the fact that we haven't detected a repeat might indicate that advanced civilizations are rare, transient, or communicate in ways we cannot yet comprehend. Conversely, if it was natural, its uniqueness reminds us of how much we have yet to learn about cosmic phenomena. The WOW signal serves as a permanent monument to human curiosity, evidence that we're asking the right questions, even if the answers remain elusive. It represents the essence of scientific exploration, the courage to seek answers to fundamental questions, regardless of how disquieting those answers might be. The WOW signal has generated decades of intense debate within the scientific community, creating a fascinating spectrum of interpretations from some of the world's most respected astronomers and physicists. On one end, skeptics like astrophysicist and renowned skeptic Michael Shermer maintain that extraordinary claims require extraordinary evidence, and a single, non-repeating signal simply doesn't meet this threshold. They argue that the vastness of parameter space in radio astronomy means that statistically, unusual events will occasionally occur by chance alone. In the middle ground, scientists like Jill Tarter, former director of the SETI Institute, acknowledge the signal's intriguing properties while emphasizing the need for cautious interpretation. She notes that while the signal matches what they were looking for, science requires repeatability and verification. On the more optimistic side, researchers like Avi Loeb of Harvard's Galileo project point to the signal's perfect characteristics as potentially indicative of artificial origin, arguing we should take the possibilities seriously while continuing to search for similar phenomena. This diversity of scientific opinion reflects the fundamental nature of the mystery. The WOW signal sits precisely at the boundary between known physics and potential paradigm-shifting discovery. The very fact that respected scientists can examine the same data and reach different conclusions speaks volumes about both the signal's compelling nature and the rigorous standards of modern science. Beyond academic circles, the WOW signal has embedded itself deeply into global popular culture, becoming a symbol of humanity's cosmic curiosity. The signal has inspired musical compositions from classical orchestras to electronic artists, who've attempted to translate its mathematical properties into sound. It appears in video games as Easter eggs and plot devices, in television series from science fiction to documentaries, and in countless novels exploring first contact scenarios. Internet communities have spawned elaborate theories and discussions, with amateur astronomers and citizen scientists conducting their own analyses. The signal's simple, powerful visual, those 6 alphanumeric characters circled in red, has become an instantly recognizable icon, appearing on t-shirts, posters, and artwork worldwide. This cultural adoption speaks to something fundamental in the human psyche, our deep need to believe we're not alone in the universe, and our fascination with the possibility of answers to ancient questions. The WOW signal has become a rare bridge between complex scientific research and public imagination, demonstrating how a single mysterious event can capture humanity's collective consciousness and inspire wonder across generations and cultures. Ironically, the very mystery of the WOW signal has driven significant technological progress in radio astronomy and signal processing, regardless of its ultimate origin. The signal's detection exposed critical limitations in 1970s observational technology, particularly the inability to conduct immediate follow-up observations. This realization spurred development of multi-site verification systems and rapid response protocols now standard in transient astronomy. The signal's unique characteristics drove improvements in radio frequency interference filtering algorithms, as engineers sought to better distinguish potential artificial signals from human-made noise. The need to reanalyze historical data led to advances in digital signal processing and archival data mining techniques. Furthermore, the signal's prominence helped justify funding for more sensitive radio telescopes with broader sky coverage. Technologies originally developed to hunt for similar signals have found applications in other fields, from medical imaging to telecommunications. The wow signal thus represents a fascinating phenomenon in the history of science. Even an unresolved mystery can produce valuable technological dividends, pushing researchers to develop better tools and methods that benefit multiple scientific disciplines. Its greatest legacy may not be the answer it provided, but the questions it forced scientists to ask about their own capabilities and limitations. The enduring mystery of the wow signal continues to inspire new generations of scientists who are approaching the search with fresh perspectives and tools undreamed of in 1977. Young radio astronomers are applying machine learning and artificial intelligence to existing datasets, searching for subtle patterns that might have been missed by earlier analyses. Astrophysicists are developing new theoretical frameworks to explain both the signal's origin and its puzzling singularity. The next generation is also expanding the search beyond radio waves to include optical lasers, neutrino detection, and even searches for theoretical physics signatures. Graduate students choose their research topics specifically to investigate aspects of the wow signal mystery, bringing contemporary mathematical approaches and computational techniques to bear on the problem. International collaborations formed by young scientists are creating global monitoring networks that can provide instant verification of any future detections. These researchers stand on the shoulders of Ehman and his colleagues, but they're equipped with technological capabilities that transform the nature of the search. For them, the wow signal isn't just history, it's a living scientific problem, a challenge that represents the cutting edge of humanity's quest to understand our place in the cosmos, and a reminder that the biggest discoveries often come from paying attention to anomalies that don't fit established paradigms. In our increasingly digital world, the analog nature of the wow signal's discovery presents both challenges and opportunities for preservation and continued study. The original computer printout is now a carefully preserved artifact, its paper fragile and ink potentially fading, requiring climate-controlled storage and periodic digital scanning. Meanwhile, researchers have worked to create high-fidelity digital models of the original signal, accounting for the specific characteristics of the big ears instrumentation and the limitations of 1970s recording technology. This process involves painstaking work to understand exactly how the telescope's analog systems would have responded to such a strong signal, and how that response was encoded into the alphanumeric printout. The effort highlights a broader challenge in modern science, ensuring that today's digital data remains accessible and interpretable for future generations, unlike many early computer formats that have become unreadable. The wow signal thus serves as a case study in scientific preservation, demonstrating the importance of maintaining not just data, but also the contextual information needed to understand it. As technology continues to evolve, this single 72-second event from 1977 continues to teach valuable lessons about how we preserve and interpret our scientific heritage for the future. The wow signal forces us to consider humanity's place within a cosmic timeline spanning billions of years. If the signal was artificial, its source likely lies hundreds or thousands of light years away, meaning we were hearing a message from the distant past, a civilization that might have risen and fallen before humans ever walked the earth. This perspective fundamentally challenges our anthropocentric view of the universe. We must consider that technological civilizations might be ephemeral phenomena in cosmic terms, their transmissions creating brief, overlapping bubbles of communication in the galaxy. The silence following the wow signal could indicate we're listening to a civilization that no longer exists, a ghost from the cosmic past. Alternatively, it might represent a civilization so advanced that their normal communications are incomprehensible to us, and we merely detected a fragment of their technology. This temporal dimension adds profound philosophical weight to the signal. We're not just searching through space, but through time, attempting to connect with intelligences that may be separated from us by gulfs of time as vast as the distances between stars. The wow signal becomes a potential message in a cosmic bottle, cast into the ocean of spacetime, with no guarantee the sender still exists to hear our reply. The unresolved mystery of the wow signal has become a driving force behind next-generation astronomical facilities. The Square Kilometre Array, SKA, scheduled to be the world's largest radio telescope, will possess such sensitivity that it could detect Earth leakage radiation levels from the nearest stars. Its unprecedented survey speed will allow comprehensive monitoring of millions of stars, making the search for another WOW-like signal dramatically more systematic. Meanwhile, the James Webb Space Telescope and future 30-meter class optical telescopes can search for biosignatures and technosignatures in exoplanet atmospheres. Advanced LIGO and future space-based gravitational wave detectors might even identify engineering projects of unimaginable scale. These facilities represent the culmination of decades of technological progress since 1977,
9,
each capable of addressing
8,
different aspects
7,
of the WOW.
6.
Signal
5,
mystery.
ready to start.
They'll work
2,
in concert,
1.
creating a multi-wavelength, multi-messenger
Booster
approach to the search
ignition
for
and liftoff of
extraterrestrial
Shuttle
intelligence
Endeavour,
that would have been
NASA's
pure
final
science
space
fiction
station
when the big
compartment
year was
that brings
operational.
a bay window view to our
The
celestial
WOW.
backyard.
Signal's legacy is evident in the design requirements of these instruments. Each carries the hope that with better tools, we might finally solve the mystery that began with 6 alphanumeric characters on a piece of paper. Modern reanalysis of the WOW. Signal reveals astonishing precision in its characteristics that continue to baffle scientists. The signal's frequency of 1420.4056 MHz matches the hydrogen line with remarkable accuracy, far closer than any known natural phenomenon. Its bandwidth was less than 10 kHz, extraordinarily narrow for a cosmic source but typical of engineered communications. The signal's intensity profile forms a near-perfect Gaussian curve as it passed through Big Ear's beam, rising and falling with mathematical precision over exactly 72 seconds. Advanced statistical analysis shows the probability of such a signal occurring randomly is vanishingly small, less than 1 in 10 million in some calculations. Computer modeling of the telescope's response confirms the signal was definitely celestial, not terrestrial. Each parameter, when examined individually, might be explainable, but their simultaneous occurrence defies conventional explanation. Contemporary researchers use sophisticated signal processing techniques unavailable in 1977, including Fourier analysis and wavelet transforms, to extract every possible bit of information from the original data. These detailed examinations consistently reach the same frustrating conclusion: the signal matches precisely what theorists predicted an artificial interstellar beacon would look like, yet its singularity prevents definitive classification. The WOW! Signal mystery has fostered unprecedented international collaboration in astronomy and SETI research. What began as a single telescope in Ohio has evolved into a global effort involving institutions across continents. The Breakthrough Listen initiative combines resources from the United States, United Kingdom, Australia, and China, creating the most comprehensive search program in history. Meanwhile, researchers from Japan, India, and the European Union contribute specialized expertise in signal processing and data analysis. This collaboration extends beyond professional scientists. Amateur astronomers worldwide monitor the WOW. Signal region and citizen science projects like SETI at Home have involved millions of volunteers. The signal has become a unifying focus for humanity's collective curiosity, transcending national boundaries and political differences. Regular international conferences dedicated to the signal and similar anomalies facilitate knowledge sharing and coordinate observational campaigns. This global cooperation represents perhaps the most positive legacy of the WOW. Signal, it reminds us that fundamental questions about our place in the universe can bring humanity together in common purpose, demonstrating how scientific curiosity can build bridges between cultures and nations. Ultimately, the profound impact of the WOW. Signal stems from what it reveals about humanity itself. This single anomaly has captivated our species for nearly half a century, not because of what we know about it, but because of what we don't know. It represents the essence of scientific curiosity, the drive to understand the unknown, to seek answers to fundamental questions about our existence. The signal touches deep psychological needs, the desire for connection, the fear of loneliness in the cosmos, the wonder about what might be possible. It inspires both humility, reminding us of how little we know, and ambition, driving us to build better tools and ask better questions. The WOW! Signal has become a modern cultural touchstone because it embodies the most noble aspects of human nature: our capacity for wonder, our persistence in seeking truth, and our courage to confront the possibility that we might not be alone. Whether it was a natural phenomenon or an artificial message, its true significance may lie in how it has shaped humanity's view of itself and our relationship to the cosmos. As we reach the present day, the wow signal remains exactly what it was in 1977, a perfect, beautiful, and utterly mysterious question mark written in the language of the cosmos. It has survived decades of scrutiny, evolving from an intriguing anomaly into a permanent part of humanity's scientific and cultural heritage. The signal continues to inspire new research, new technologies, and new generations of scientists. Its legacy is not an answer, but a better understanding of the questions we should be asking. The wow signal taught us humility in the face of cosmic mysteries and perseverance in seeking solutions. It showed us that the universe is capable of surprises that defy easy explanation, and that the search for understanding is a journey without a final destination. As we continue to listen to the stars with ever more sophisticated instruments, the ghost of those 72 seconds in 1977 reminds us that the greatest discoveries often come from paying attention to the anomalies, the outliers, the data points that don't fit. The wow signal endures as a beacon of curiosity, a reminder that the universe is far stranger and more wonderful than we can imagine, and that our quest to understand it is one of the most noble endeavors of the human spirit. From a single red inked notation on a computer printout to a global scientific mystery, the wow signal has come to represent humanity's eternal quest for connection in the cosmos. It has taught us to listen more carefully, to question more deeply, and to never stop wondering about what might be out there. The signal's true meaning may never be known, but its legacy is certain. It has forever changed how we see our place in the universe, reminding us that sometimes, the most important answers are the ones that remain just beyond our reach, inspiring us to keep searching, keep wondering, and keep saying, wow.